God, the name is so difficult and scary, right? Theorem on compound probability. Don't worry, it is very, very easy concept, okay? So let's understand this concept with the help of one simple example. Example is already flashing on your screen, right? So, see now, find the probability of drawing a queen and a king in that order from a pack of cards. In that order, important, highlight, underline, okay? In two consecutive draws, when the card is drawn are not being replaced, being replaced, okay? So we are going to solve both of these parts to understand this concept, okay? First is what? Not replaced, okay? Not replaced, and here the cards are replaced. And what's the event they are saying? Two cards are drawn one by one, right? First one needs to be what? Queen, and second one needs to be what? King. So now you must be knowing the basics of cards. I am not going to go into that detail right now in this video because I have covered those details or those introduction of cards in many previous videos. You can refer to those. So you know that there are in total 4 queens and there are in total 4 kings in a pack of cards. And how many total cards? In total cards, 52 total cards in one pack, correct? These many details are enough to solve this example, okay? What is event A? Say event A is drawing first card which needs to be queen, correct? So, what is the probability of happening of this event? So, there are, as I said, 4 queens, favorable outcomes divided by total outcomes. How many are total outcomes? 52 right now, okay? Now see, not replaced. So, what does it mean? One card is drawn and that is kept aside, not replaced, and then from the remaining bunch of cards or remaining cards, you are drawing the second card, okay? So that is not replacement meaning. So after this event is happened, how many total cards are remaining now? 51, correct? Now 51 cards are remaining. You are drawing what? One queen, correct? So how many queens are remaining now? 3 queens are remaining, okay? We just don't need this part, but just for logical explanation purpose, I am telling you that this one card is drawn, which is one queen out of those 4 queens, and you have kept that card aside, correct? And in effect, in total cards are reduced to 51 now, okay? So what is event B? Draw one next card, which needs to be what? King, yes? So what is the probability of happening this event B? What's the probability? There are 4 kings, correct? So 4 favorable outcomes divided by, what are all the possible outcomes or total outcomes? 51 right now, correct? So 51, yes? Now what are they saying? Total probability of happening of this event. What's the actual event? That first card needs to be queen and the second card needs to be king. And, correct? This and is super important, okay? Means probability of happening of event A and probability of happening of event B. I have very much in detail explained that multiplication means and addition means or, okay? I would just write it down in this video also for your reference. Multiplication means and, addition means or, okay? So the detailed explanation of these two things are there in the other video, okay? Not going in those details now. Can I say that this event is nothing but A and B, right? So and can be represented by this symbol, right, which is intersection, correct? And means intersection, correct? When you do it with the help of Venn diagram, you always say that this common vision is what? And, which covers both the events. So A and B. Easy way to remember this is what? When it makes something like A symbol, that is your and, okay? That's, my trick for you, okay? So and is basically intersection, correct? Which should cover both the regions. So I can very well say this, okay? And now what is it? Probability of A for sure, and means multiplication. Probability of B when event A has happened. When event A has happened, represented like this. This is read as probability of B by A. Means probability of B only you are supposed to find out when A has happened. And why do we have to write it like this? Because of the dependency of the events, right? B is dependent on A, correct? Because the event A happened, this set is reduced to 51, right? And that is indicated this way. Now let's put the values, okay? Probability of A is what you have already found it out, 4 by 52 into probability of B is what? 4 by 51, okay? See, this just the representation I am changing here, right? This is probability dependency here, right? Just by looking at this, one should understand that okay, event B is dependent on A and we are trying to find out the probability of B when A has happened or occurred. Okay, so this is the final answer of your question. This can be also represented as what? A and B, right? A intersection B means A and B means means multiplication. That is nothing but A into B. Okay, so what you can conclude from this basically is this intersection is equivalent to this multiplication sign is equivalent to and. Okay, many students get confused in this specific thing, but then yes, it is clearly explained to you here. Okay, and opposite to this, which is not part of really of this video, but still I will tell you, when it is union, it is or, which can be also written as or. Okay, plus sign means or. We already know that part, right? Just about union and intersection. People get confused with this union and intersection. So you can remember it this way. When it is and, it should make like A. Okay, that is intersection sign. Alright, so let's move to the second part of this example where the replacement is allowed. Okay, event is same. Okay, so what is event A? That first card which you are drawing needs to be what? Queen. So what is the probability of happening of this event? 4 queens are there, total 52 cards are there. Same up to this, no any changes, right? Now what is event B? The next card which you are drawing needs to be king. Okay, but now is there any change in this sample space? In sample space there are in total 52 cards, correct? As you are replacing that card again, means you are drawing first card which is queen, you are again mixing or replacing that card, or you are keeping that card back in that pack of 52 cards, right? Means one card is not reduced, and again you are drawing the second card out of that 52 card set. Okay, so probability of B is what? You are drawing one king. There are in total 4 kings, so 4 favorable outcomes. Out of how many cards? Now out of 52 cards only, right? Which gives you what? Probability of this event. First card needs to be queen and second card needs to be king, right? Now you have to write it down like this only because these are independent events. Here those are dependent events, and that is why you have written it down like this. See, the ultimate result or ultimate value which you are going to take is probability of B only in both the cases. But this is just about the representation to understand the dependency and independency. Okay, so now this indicates that these two are your independent events, right? Whichever happens first, even if the first event is like you draw king first and then you draw queen, still it is not going to make change your result basically, right? Because of the independent events. Okay, let's put the values quickly. So both are like 4 by 52 into 4 by 52, and that's your answer to this question. I have already told you probability of E is nothing but what? Probability of A and B, right? A and B. This and is nothing but what? A, this and means intersection of B. This is nothing but what? A and B. Okay, so you have to remember this thing. I hope this concept is clear to you. The important formula to remember in this is this. Okay, and obviously this. See, now these two are actually the same formula only, right? When they ask you the probability of A and B, we have already seen the probability of A or B, correct? When it is or, that is addition theorem. We have seen it in the previous video. And when it is and, probability of A and B, in that case this is nothing but the theorem on compound probability. And this is the exact same formula. You can remember any of it. Just in case of dependent events, you have to show it or represent it like this. When those are independent events, you can represent it like this. Okay, otherwise the formula is very simple, that okay, they are asking probability of A and B, so it has to be probability of A and means multiplication, probability of B. As simple as that, right? We have already done many practice examples for this concept, right? You can watch my rapid one-shot video on probability. That covers many nice examples, okay, and variety of examples. So I hope this concept, theorem on compound probability, is clear to you now, and the formula for this is written down here. So yeah, keep studying, keep practicing. If you like my video, please like, share and subscribe to my channel and share it with the friends, with your friends or who needs to watch my videos basically. Okay, see you in the next video. Bye bye.